and now we're going to pick up where we left off last time when we discussed really actually a couple of definitions. One being the definition of the number of inversions in a permutation, or what an inversion is, and the next being a definition of a parity of a permutation. And if those definitions seem a little fuzzy to you, it's probably a good idea to go ahead and go back and review those. I know the definition of the inversion is a little weird, but make sure you're comfortable with those. So, but on to proposition 3, which states that given any permutation alpha 1, alpha 2, all the way to alpha n, if two adjacent terms are interchanged, then the parity is interchanged. Here comes that proof. Alright, consider two adjacent terms, alpha of I and alpha of I plus 1. Those are adjacent because the I and the I plus 1, those are the positions of the numbers. So those are adjacent terms in the permutation. If alpha of I is less than alpha of I plus 1, then interchanging the two results in an additional inversion, thereby changing the parity, right? So if it was even before, right, and in the case that alpha of I is less than alpha of I plus 1, if I switch them, I've added an inversion, and now if it was even, now it's odd. And if it was odd, then now it's even. Okay, so the other case. If alpha of I plus 1 is less than alpha of I, then interchanging the two results in the loss of an inversion, thereby changing the parity. Okay. Thus, in either case, interchanging adjacent terms in a permutation changes the parity, right? Either way, if I'm adding an inversion or subtracting an inversion, I've changed the parity from even to odd or from odd to even. Doesn't really matter. Anytime I interchange two adjacent terms, no matter what, I've changed the parity. QED. Okay, that's proven. And next time we'll go ahead and prove, I know this one was easy and short, but next time we'll prove proposition 4, which states that a permutation is even if and only if it can be written as an even number of transpositions, and odd if and only if it can be written as an odd number of transpositions. That's next time. See you then.